Good evening, everyone. For today's video, we will discuss about probabilities and normal distribution. Okay, here, standard normal distribution. This is a distribution of a normal random variable with mean of 0 and a standard deviation equal to 1. A normal distribution, sometimes called a Berg curve, because ang graph niya kay bell, mura siyag bell ano oh. Di ba ang bell kay na siya ana bell. So bell curve or like this. Ana no. So it's a distribution that occurs naturally in many situations. Again, occurs naturally in many situations. Para sa anang grado ninyo sa math, test scores ninyo. So sometimes or rare na kaayo sa is ang graph ninyo ana sa inyong scores, grado or test paper. Some of the group ang graph ana kay pormagin ana. Okay? And Gaussian distribution is another name for a normal distribution. Why? Because as you can see that Gaussian distribution, which is um, the term Gaussian distribution and normal distribution are used interchangeably because they differ to the same probability distribution. The reason for this interchangeable use lies in the historical context and the contribution of the mathematician as called Carl Friedrich Gauss. Okay, correct me if I wrong how to pronounce it, the name, because he is the prince of mathematics, one of the most have a lot of contribution in number theory and so on and so forth. Okay, Carl Friedrich Gauss, a German mathematician, made significant contribution to statistics and probability theory in 18th and 19th centuries. He studied the properties of bell shape or curve that is now known as normal distribution, as you can see here. However, the term normal distribution itself was popularized by Sir Francis Galton. Again, the normal distribution itself was popularized by Sir Francis Galton, a cousin of Charles Darwin na theory in the late 19th century. The mathematical properties of the normal distribution were described by both Gauss and Laplace independently, and the distribution is sometimes referred to as the Gaussian distribution, as you can see. To honor Gauss' contribution, essentially Gauss' work laid a foundation for understanding and characterizing this distribution, which is why it is often associated with his name. No. And then, in summary, the Gaussian distribution and the normal distribution are two names for the same probability distribution that has a bell-shaped curve. The terms are used interchangeably to describe a continuous probability distribution that is symmetrical and characterized by its mean and standard deviation. So, mo na siya, no? And then, as you can see, i-reason na to ni. As you can see here, in statistic, a normal distribution is called, sa statistic pa, ang normal distribution called normal curve. Normal curve like this. Ano siya? Normal. Equal ang mean, median, and mode. Okay? Kapag sabi natin normal, which is there is no outliers at all. Dili skewed to the right, skewed to the left. It means 50%, 50% balance. Okay? Not totally perfectly, but maybe is kanang makita nimo na normal curve siya or bell curve. In social science, it is called the bell curve because it is shaped the bell, like this. Okay, the bell curve. And P6 is called Gaussian distribution. So, statistics, social science, and physics. P6, which is lain tawag ana. Okay, but today, our video is relate to the statistic, which is data management. Therefore, we called it normal curve. Normal curve. Now, here are the properties of normal distribution. The mean and the mode and the median are equal. Again, equal. When we say normal curve, the mean, median, and mode are equal. Okay, the mean, the mode, and the median are equal. That is the first properties. The curve is symmetric at the center around the mean. Okay, muna siya. The third, exactly half of the values are to the left of the center and exactly half of the values are right. So this is the left and the right. So 50% of the values are equally divided. Okay? Because kani tanan is 100% man siya sa total distribution sa dataset. Number 4, the total area under the curve is 1. Muna siya, the total area under the curve is 1, which is 100%. Okay? That, so, muna siya. But before that, let us know here that what is a probability. Let me show to you. Okay, probability and the normal distribution are fundamental concept in statistics. And probability theory, which is show that um, probability and the normal distribution are fundamentally concepts in the statistic and probability theory serving a various purposes across different fields. And here an overview of their purpose and usefulness of probability. Probability. Okay, so the first is the quantifying uncertainty. Okay, so pag-pronounce ani. Okay, probabilities provide a quantitative measure of uncertainty. Sorry for that. They express the, again, probability. It is a likelihood, more on likelihood. Provides, quantifies, it quantifies, no? Quantifies. Muna siya. It quantifies the outcomes. Okay? Or the likelihood of different outcomes in the probabilistic event. Okay. And also, decision making. Probabilities help in decision making by providing a rational basis for assessing risks and benefits. They guide choices under uncertainty. Okay? So, muna siya sa decision making. Kung patay kag loto, dako bag chance na budaog ka. O decision making. Kung pautangon nimo ni siya, dako ba ang chance na mobayad siya utang kaning friend nimo? Or magnegosyo ba ka sa business, dako bag chance or likelihood sa decision making nimo na chance na mulambo because it quantifies outcomes. And also inferential statistic. Probabilities are essential in inferential statistics where they help make prediction or inference about population based on samples. Example, if you have a coin, if you clip it head and tail, if you clip it 50-50%. So I will predict that head ang mugawas. So 50%. So inferential statistic, more on prediction. I will predict that ang mugawas is head. Okay? And also risk assessment. In finance, insurance, and other risk-related fields, probabilities are used to assess and manage risk. These include calculating the probability of events like defaults, accident, and market situation. Muna siya, ha? Then also machine learning and AI, artificial intelligence. Probabilistic models are widely used in the machine learning and artificial intelligence for tasks like classification, regression, and natural language process. And the next is evaluating hypotheses. Probabilities are used in hypothesis testing to assess the likelihood of obtaining observed data in a certain hypothesis is true. The hypothesis, which is the null hypothesis, and the alternative hypothesis, if there is a significance, correlation, and difference or frequencies okay, in the frequency statistical tests like by binomial, chi-square tests, and so on and so forth. And also game theory. Probabilities play a crucial role in a game theory, helping analyze strategic interaction and decision making in a competitive situation, like the basketball and the volleyball. Basta games, is taas ba ang chance na budaog ang grupo mo na siya, ha? Based sa mga player. So, laban lang jud ta. Okay? So, again, normal distribution. Modeling real-world phenomena. So, the normal distribution, also known as a bell curve, is often used to model and describe the distribution of many natural phenomena such as height, IQ scores, and measure of errors. So, sa IQ, if kanina IQ is dako bag chance na makapasar ba siya sa exam. So, probably, he make the test, no? Ano siya. Also, the central limit theorem. The normal distribution is the key components of the central limit theorem, stating that the distribution of the sum or the average of the large number of independent, identically distributed random variables approaches to the normal distribution regardless of the original distribution. So this is the central limit theorem. And also, statistical inference. Many statistical methods, including hypothesis testing, and so on and so forth, confidential interval estimation assume or work well when the underlying distribution approximately normal. And the next is the standardization of z-scores. Again, the z-scores. As you are familiar with, the normal distribution is useful for standardizing data through the calculation of z-scores, allowing for comparison and statistical analysis across different scale and units. So, as you can see, dito sa z-scores nato is na-discuss naman nato to if nakakuha kag mean and standard deviation pila ay mohang standard scores, no, kung layo pila ka unsa ka kalayo sa mean sa standard deviation and asa ka nabutang dito sa probability sa percent na siya. So dagan pa ni sila sa kuan. Now let's discuss about what is this meaning of empirical rule. So here the empirical rule. So let me erase this to you, the definition of the probability. Now let's go to the empirical rule. This is the most important things. So as you can see in the table, I will show to you that here, this is the table that you will see. So as you can see here, no, nabantayan ninyo, which is 0, 1 standard deviation, and 2 standard deviation, and 3 standard deviation, positive, which is above. And here is the negative, which is below the mean, below the standard deviation, which is 1, negative 1 represent as 1 negative standard deviation below the mean. Okay? And negative 2 and negative 3, which is kanitanan is equal na sila sa 100%. And then divide. So kabantay mo atong property sa normal distribution, no, 100 to sila. So malaman ninyo ni kung unsa ni siya. So nga ta ginaingon na additionally, every normal curve, kapag normal curve, regardless of its mean and standard deviation, conforms the following rules. 68% of the data under the curve falls 1 standard deviation of mean. So kani siya 1 standard deviation of the mean, which is represent as 68%, because 34 plus 34, which is 68%, 0.2. Okay, 68 percent point 2. Okay, muna siya, which is standard, one standard deviation kani siya dire, which is represent as 68%, no? In here, 95% of the area under the curve fall within two standard deviation of the mean. So gikan dire hanto dire, kani sila, hanto dire, oh, within the two positive standard deviation 2 and negative 2 standard deviation above the mean and below the mean, which is kani sila na mga data represent as 95%, pero gidivide lang siya into half, equal, no? 34 plus 34.1, which is 68.2, then 13.6 plus 13.6, which is 95%. Okay, here the three standard deviation, which is 99.7%, which is gidivide siya, so diri gikan the above the mean, the three standard deviation, and the below the mean, the three standard deviation, which is ang total ani sila tanan, which is 99.7%. Okay, that is the rule of empirical rule, 68, 95, and 99.7%. So as you can see, ang sobra na lang ana is napay 0.01 dire, which is kung i-add mo na tanan, at magresulta sila 100%. Okay, that is the empirical rule. Okay, understood? Next is the discrete probability function. Okay, so discrete probability function is also known as the probability mass function and can assume a discrete number of values. For example, coin toss and counts of events are discrete function. These are discrete distribution because the number in between the values. An example, if you can have only heads and tails, coins. So if you are counting the number of books, so sa books wala man joy half na books, no. Buo man joy na sila. That's why gitawag siya discrete. Okay? So example, count 21 or 22 books. So mo na siya ha. So continue lang ko unya nga po i-checkan. So okay na ni. Then palihog ko pakikuha sa inyong test paper. Then plus 10. Direct to the blue book. Pakikuha na lang sa grupo ninyo. Tara ah. Muna siya. Okay guys, so muna ang pasabotan ng discrete probability function. Now, let's go to the continuous probability distribution. Okay, so from the word continuous, the probability function are also known as probability density. Probability density function. You know that there are continuous distribution of the variable can assume infinite numbers of the values between, again, between any two values. Continuous variable often measure a scale such as height, weight. So kung magpatimbang ka, dili lang pasabot na exact jud na 80 kilos ka, nga pa na siya mga point. So therefore that's why gitawag siya continuous variable. Example sa temperature, nga man mga point. So again, between any two values. So that is the definition of continuous variable. And now, next video, I will discuss to you how to solve or how to use the normal distribution, no? And how to use this table, how to use this one correlated to this problem. Okay, thank you so much.